Every device you touch today, your phone, your car, your laptop, even your washing machine, runs on chips. And roughly 90% of the most advanced ones come from one island, Taiwan. Mostly from one company. That is the most important supply chain on Earth, and everyone is fighting over it. In the next few minutes, you get the whole chip war, minus the jargon. The 2-nanometer race between TSMC, Samsung, and Intel. NVIDIA versus everyone. America versus China. India's first real fabs. And my honest take on who is actually winning. Plain English, verified numbers, no hype. Let's go. First, why should you care? Because chips are the new oil. A modern car carries over 1,000 of them. Your phone, your bank, the power grid, every AI model you have ever used, it is all silicon underneath. When chips ran short in 2021, car factories stopped. Governments never forgot that. Quick decoder before the fight card. A chip is billions of microscopic switches called transistors. Smaller switches mean faster chips that sip less power. 2 nanometers is a marketing label, not a real measurement. But the jump is real. TSMC says 2 nanometers cuts power use by up to 30% versus the last generation. Here's the wild part. Only 3 companies on Earth can manufacture chips at the leading edge. TSMC in Taiwan, Samsung in South Korea, and Intel in America. Not 300. 3. Everyone else, including Apple, NVIDIA, and Qualcomm, only designs chips, then stands in line at these 3 foundries. So, state of the race as of mid-2026. TSMC's 2 nanometers process entered volume production in late 2025, with reported yields around 70%, meaning 7 of every 10 chips come out working. That is excellent this early. Its Taiwan fabs are effectively sold out, and 2 nanometers phones land this year. Samsung actually moved first on paper. Its Exynos 2600, unveiled in December 2025, was the world's first 2 nanometers phone chip. The catch: Samsung's yields have historically trailed TSMC's, so big outside customers stay cautious. Its improved SF2P process ramps late this year. Samsung has the tech. It needs a marquee win. Then there is Intel, the comeback story. Its 18A process, roughly 2 nanometers class, entered production in 2025 and powers its newest laptop chips this year, with an upgraded version coming in the second half. The question is not whether 18A works. It is whether outside customers trust Intel's foundry with their designs. Zoom out, and the picture gets stark. TSMC's share of the whole foundry market hit 72% in early 2026. At the leading edge, it is over 90%. Samsung and Intel split the scraps. When one company makes 9 of every 10 advanced chips, that is not a market. That is a choke point. On top of those factories sits NVIDIA. It designs the AI accelerators everyone is fighting over and still holds roughly 80% of that market, down from about 92% in 2023. Note the direction: dominant, but slipping. And remember, NVIDIA manufactures nothing itself. TSMC builds nearly all of it. Who is taking those points? AMD holds maybe 5 to 7%, but the real movers are NVIDIA's own biggest customers. Google's TPUs, Amazon's Trainium, Microsoft's Maya, Meta's MTI. Custom chips built to dodge NVIDIA's prices. Custom silicon shipments are growing nearly 3 times faster than GPUs this year. So why has NVIDIA not collapsed? One word: software. CUDA, its programming platform, carries nearly 20 years of code, tools, and trained developers. Switching to another chip means rewriting your whole stack, and nobody wants that bill. Hardware gets you into this race. Software is what keeps you winning it. Now the geopolitics, handled calmly, because the facts are dramatic enough. Governments treat chips like oil, strategic infrastructure. America's CHIPS Act committed $52 billion. Europe put up 43 billion euros. China has spent far more across a decade of state funds. Why? Because whoever controls compute controls how fast their AI improves. Since 2022, America has blocked its best AI chips from reaching China. In January 2026, the rules shifted. NVIDIA's H200 can now ship there, but with a 25% tariff and certification against military use. The newest Blackwell chips remain banned. Think of it as a valve now, not a wall. China's response is to build everything at home. SMIC now makes 7 nanometers chips without the newest Western machines. Huahong is readying a second 7 nanometers line. Huawei is targeting over 1.5 million Ascend AI chips this year, and Beijing pushes a domestic chip deploy for every imported one. So who is actually ahead? Analysts estimate America will produce somewhere between 21 and 49 times more AI compute than China in 2026, depending on how you measure. That is a massive gap. But controls cut both ways. They slowed China at the frontier and handed its chipmakers a guaranteed home market. Which brings us back to Taiwan and the phrase Silicon Shield, the idea that the world cannot afford a conflict there because TSMC is irreplaceable. The numbers back it up. TSMC booked $35.9 billion in a single quarter this year. That is leverage and a single point of failure simultaneously. Hence the global fab construction boom. TSMC is spending $165 billion in Arizona, and its first fab there already turned a profit. Samsung's Texas plant targets 2027. TSMC's joint venture in Dresden, Germany aims for late 2027. But notice, the newest 2nm lines stay in Taiwan this decade. Now the angle most Western coverage skips, India. Over $21 billion in chip projects are approved under the India Semiconductor Mission. For a country that imported virtually every chip it used, this is a real shift from buying its digital future to manufacturing at least part of it at home. The scoreboard so far. Keynes shipped India's first commercially packaged chips to a U.S. client in October 2025. Micron's assembly and test plant in Sanand opened in February 2026. And the big one, Tata's $11 billion fab, is past halfway built, targeting trial production in December 2026. Real talk though, Dollar starts at 28 nanometers, technology the leaders ran 15 years ago. Embarrassing? Not really. 28 nanometers is the workhorse node inside cars, appliances, and industrial gear, where volumes are huge and demand is steady. Taiwan started behind too. Nobody enters this industry at the front of the line. One reality check for everyone, actually. A leading-edge fab costs over $20 billion. A single EUV lithography machine runs past 200 million, and only ASML in the Netherlands build them. American designs, Dutch machines, Japanese chemicals, Korean memory, Taiwanese fabs. Nobody, not even America or China, does this alone. My take: chip wars do not end with a winner. What is really happening is de-risking, not decoupling, and every duplicate fab quietly makes your next device a little pricier. Here is the uncomfortable truth: the interdependence is the point. Mutual dependence, for all its stress, beats the alternative. And this race has no finish line. 1.4 nanometer chips are already on roadmaps for around 2028. But watch the quieter bottlenecks: advanced packaging, high bandwidth memory, and plain electricity for data centers. The next chip crisis probably will not be about nanometers at all. It will be about power. If the chip war finally makes sense now, subscribe. Tech Batu does plain English breakdowns like this every week, no hype attached. And your turn. Should India chase cutting-edge 2 nanometers or own the workhorse 28 nanometers market first? Drop your answer in the comments. I read every one. See you in the next video.